Good afternoon, everyone. My name is Jad Boutros. I work at Snapchat, and specifically, I'm responsible for security, spam and abuse, and privacy engineering. And the talk today is very much at the intersection of those three areas. So because this is the first time we give a talk at a security conference, I thought it would be nice to just spend a few minutes talking a bit about our security program at Snapchat. And then we dive into the main point of this talk, which is third-party app abuse. And the way we want to do this is first tell you a little bit what is the problem that we're dealing with, how does it affect Snapchat, and then talk about some of the solutions we've been implementing for some time now, starting with server-side solutions and then augmenting them on our mobile clients for Android and iOS. And then talk about where we are today with this issue and leave you with some sort of closing thoughts. So I joined Snapchat almost 2 years ago, and I was the first full-time person on security and spam and abuse. Up until then, Snapchat was a startup in the true sense of the word. There were fewer than 20 developers at Snapchat. And if ever there is a spam issue, for example, one developer would have to stop what they're doing, go address the spam issue. When it's resolved, return to their normal work. Today, the situation is very different. Snapchat has over 250 developers, and our own team has about 20 engineers. We've implemented a lot of security, privacy, and vendor review processes. So we have privacy by design, we have security by design, and also we do due diligence for security and privacy whenever we're working with a new vendor. And sort of to put some numbers don't mean much, but they give you a little bit of perspective. For all of 2015, we conducted more than 140 security reviews. So that includes design reviews for security. It also includes pen testing, application source code audit, and fuzzing, whatever was needed. And we also did more than 550 privacy reviews. So anytime there is a new functionality at Snapchat, we do a privacy by design first. We also worked on due diligence and security and privacy reviews for more than 70 vendors. And obviously, sort of depending on the sensitivity of that vendor integration, we either do a deeper dive. If there is, for instance, integrating with our app, we take them more seriously. And if it's a vendor that is very peripheral to security and privacy with much lower risk, then we do a lighter review. Also in 2015, we launched a vulnerability rewards program on HackerOne. We started at first in a private mode, just to iron out the quirks, communication, the flow, and then we opened it up to the public on April 2nd. By pretty much all measures, it's been a successful program for us. We've interacted with the security community, we received bugs, we worked on them, and that engagement has been very useful to us as well. Also, we've been progressively increasing our bounty payout. And really, we are looking for sort of the more serious type issues. And so we're always looking at ways to entice researchers to probe for these. For instance, accessing someone's snaps that you shouldn't be able to view and things like that. We also used to have an account management website, but it wasn't written with security in mind initially. So when we joined, we rewrote it from scratch using the best security defenses that we knew of. Some of them, Christoph Kern mentioned in his talk yesterday about security by design and using safe frameworks. And that's been very cool as well. We launched two-factor authentication for our users. First, it was by SMS, and then we added OTP to it more recently. We've also been, over time, strengthening our corporate security posture, which is why I'm slightly less scared today to bring my work laptop to this conference. And one thing that's been always very important to us is protecting user data that we have. And so we've been, all of 2015, we've been very focused at strengthening our internal controls. around this access to user data. And that's a project that is ongoing. It will never finish. We'll just keep trying to get better and better at it. So with that in mind, let's sort of dig into the third-party apps abuse issue. And really first, sort of what is the problem that we're tackling? Essentially, like many mobile apps, our mobile app interacts with our server using HTTP. In our case, it's HTTPS. But we have endpoints on our server that are meant to be called by our mobile clients. And we don't provide any API for other parties to integrate with us. So those endpoints that we have are meant to be used exclusively by our mobile app. So the fact that there is no public API didn't stop third-party developers from trying to reverse engineer our own and basically use them. And so they have a number of reasons why they would want to do that. For instance, it could be about providing some new photo editing option into our Snap editing. It could be about providing a different way to interact with content that we have on Snapchat. Or it could be about providing functionality we don't support. So for instance, today, we don't provide the ability for you to share from your camera roll inside Snaps. You can do that in other means, but not through Snaps. And it also could be because we support iOS and Android, but there are some platforms we don't support. So third-party apps got written for those platforms. The way they usually work is very similar. So there is a third-party app that users will download. It's not affiliated with Snapchat. And it will prompt the user to provide their Snapchat credentials, so their Snapchat username and password. And then it will use that to log in to our Snapchat servers and then access our APIs. Those apps exist in different forms, primarily mobile applications. You can find them, for instance, on the Apple App Store or Google Play. They could be on unofficial app stores. They could be web applications or even thick client installs like command line tools. The thing that is important in our case is that users don't necessarily have to exclusively use those third parties. They could be using our own. And in some cases, they want some functionality that we don't provide. They switch to a third-party app, and then they switch back to us. And really, the main point here is that we don't look at it from the perspective of the user is good or the user is bad. It's not about finding users that are bad and preventing them from interacting with Snapchat. It's about encouraging the right approaches and discouraging uses of third-party apps that could present risk. And so just to give you an example, this is a mobile application. Oh, it's a bit hard to read, but in that, this third-party app wants to provide functionality using Snapchat, so it asks the user to enter their Snapchat username and password. Now, the issue to us is that those third-party apps present risk to our platform. And really, that risk comes in different ways. In the first case, those apps will receive Snapchat credentials. So you can imagine that if they're storing these credentials somewhere and then that app gets compromised, those credentials will be leaked. Or if they gather a trove of credentials, they may decide later on to use them for potentially malicious purposes. They also interact with user content. So they might see, for instance, your Snap if you're giving them your Snap to upload. And so again, you can imagine that if that user content is stored in a wrong way or used in not great ways, then that content will be exposed to extra risks. Also, we built the Snapchat system with certain privacy, with a privacy posture. And our clients have to respect that privacy posture. But if a third-party app is written that does whatever it wants, then potentially it could circumvent those privacy controls. And you can also imagine that if someone is using our mobile apps and only our mobile apps, then the amount of spam and abuse that can happen as a result of those interactions is reasonably confined, but when you open it up to more apps, there is an increased risk there as well. And this issue sort of became more important in 2014 when one of those third-party apps got compromised. And it was, their servers got compromised, and it was found that they were storing certain user content on there. So that user content became public knowledge. When that happened, it really strengthened our belief that we should tackle this issue very specifically and prevent the kind of access from these third parties into our systems. And this is what we've been working on since. So one thing to keep in mind is that before that happened, we were augmenting our spam and abuse program. So as soon as we started coming up with defenses to combat spam and abuse issues that we recognize were happening. So for instance, we implemented defenses, rate limiting for all our endpoints, per user, per IP address. We did a fair bit of work trying to analyze IP address reputation to know which ones are potentially bad and abusive and have a way to shut them out, either temporarily or permanently block them out. And also because spammers, because of those rate limits were starting to get in place, it was getting harder for spammers to do large-scale attacks. So they resorted to creating a very large number of accounts on Snapchat to be able to use them and still stay under the rate limiting radar. And so we focused very much on preventing large-scale account registration, stopping it before it happens, or in some cases sort of stopping it shortly after, depending on what type of abuse we were seeing. And also because it's even in 2015, 14, 16, we still have the issue with password reuse across the internet. Users tend to reuse the same password on different sites. Some sites get compromised. You end up with a massive list of compromised credentials. We started putting a lot of effort on trying to identify logins that don't belong to the real user and either stop them at the source or in some cases warn the user that there was a login and suggesting they change their passwords. So all of these defenses were already well underway and they were curtailing certain forms of third-party app abuse. But we wanted to focus on that problem more specifically. And in fact, when this compromise of that third-party app happened, we saw a tweet that was directed at our CEO where it said, basically, Snapchat, what are you doing? Surely you can stop this form of abuse. Why are you letting those apps on your systems? And it was a very interesting tweet because it made us think, like naively, you could consider that we have some kind of switch that in normal mode, we allow logins from any app out there. And if we wanted, we would just toggle it to on and suddenly only our app can log into our systems. But that's not the way the internet works. There is no such switch. And if you ask the security community, everyone will tell you, or almost everyone, it's an impossible problem. You can't really prevent this sort of abuse. When users willingly give their credentials to another app that is not in Snapchat's control, that app will be able to access your APIs. But at the same time, sort of surely there were things we could consider doing to curb this form of abuse and to keep encouraging our users to do the right things and discourage them from behavior that could lead them to extra risk. So we started thinking on what can we do to combat this problem specifically. And the first ideas we had were around solutions that were server-side only. And the reason for that is simple. Up until that point, we were still accepting requests from any version of our Snapchat mobile applications, even the very, very early on ones. And so implementing solutions that are server-side would allow us to have this defense work no matter what mobile version is being used. So the appeal for that was very obvious for us. We could right away implement meaningful frameworks and have them work regardless of which mobile version a user is on. first step was for us to establish a baseline. And really what that means is strengthen the posture to put sort of the basic defenses in place to indicate that really these APIs are meant to be used by our app only. So one example is user agent. Now we know it's trivial for third-party apps to change their user agent to whatever they want, but at least if we enforce that only our user agent can talk to our APIs, we're sending a clearer message that these APIs are meant for us. Even that alone is hard to do when you support so many different versions of your mobile app. Because you go back 2 years, you don't know what format the user agent was in. And in fact, we found that some older versions of our app were not even sending a user agent in some specific cases. So you want to make sure you don't lock out also our older versions of the app. But we worked on that progressively, and we turned it on. The other thing is also to check HTTP headers. We know what our mobile apps should be sending. And so if we notice that some are missing, clearly that traffic is not coming from us. Or if we see some headers that are superfluous and again, for sure not coming from our app, we can reject those requests. And also because at the time we were supporting all these versions with so many different versions of APIs, it gave third-party developers more freedom in trying to pick and choose the ones that they're interested in. So they would use some APIs from very old versions, some other ones from newer ones, whatever made their job easier. So we started putting limits on what is possible. If you're coming from a certain mobile version, then those are the APIs you can use. We also recognized very quickly that supporting all these mobile versions just makes no sense in general. It invites abuse, and we have to curb it no matter what else we do. And so we started this effort of deprecating our old APIs, which is a bit difficult when in some cases older phones didn't support newer versions of ours. So we had to make tough decisions, sometimes communicating well in advance with those users, trying to nudge them to update. And after a certain period of time, we just completely rejected access from old APIs. One thing that happened right after we sort of turned on this user agent checking is that we saw this press article about a third-party app that claimed to have circumvented our defenses for abuse. And for us, it was sort of silly because at the time, the only thing we had done yet is user agent. That's clearly not what we had in mind. But it also sent the message that this is going to play out in the press, and we have to be careful about the messaging and about the fact that it can get sensationalized more than we would like it to be. So now, sort of getting more serious, some of the defenses, one of the defenses we thought of is let's leverage mobile notifications. So on Google, on Android, this is the Google Cloud Messaging. On iOS, it's the Apple Push Notification Service. Can we use that to better ascertain that the requests are coming from our app and not some other app? And so really, in other words, can we check that the mobile client is getting valid notification tokens, giving us valid notification tokens, and can we check that they came from our app? It turned out in the protocol that we had at the time, it sort of worked backwards to what we wanted. The user logs in via mobile app, and in the response to the login, we would send them what we think is their notification token, or at least the last one on file. And if the mobile app finds that this is no longer the valid one, because there are reasons why it could change, then the mobile app would send us a newer one. It wasn't great for us because that basically means a third-party app logins with that user's credentials, and then it receives that notification token. So there's no way for us to differentiate, is it our app or someone else's? So what we basically did is we sort of hacked our own protocol, because again, we wanted something that works for all our mobile versions. And we changed it around so that when you log in, we send you in the response a fake notification token. And our mobile app will then detect that this is not the real one, and it would communicate back to us, giving us the real one. Whereas the third-party app may not know what is the real one and can't generate a new one. So we will be able to know that this wasn't our app. We had to do this in somewhat subtle way because we don't want to send too many signals that make it very easy for others to know that this is what we're doing. And really, it relies on one thing, which is that we're able to verify server side that A, we received a token or we didn't receive one. And the token that we received is a valid, legitimate one issued by our app. So it was a good idea. In practice, it didn't work quite the way we wanted, and for different reasons. So on iOS, the first issue we came across is that the behavior of apps, particularly when a user had disabled notifications to that app, varied according to the iOS version. On iOS version 6 and 8, if a mobile app if the user had disabled notification for a mobile app, which some could do, the app could still nevertheless get a notification token from the iOS system, and it could send it to the server. The only thing it couldn't do is receive notifications. But on iOS version 7, the app would simply not get one. So already we knew that we hit a major limitation and that a third party could then pretend to be running on iOS version 7, and we wouldn't be able to differentiate it from our own app. Also, the other problem is that we had no way to validate in a very lightweight way that the token is indeed coming from our app. And given the scale that we're dealing with at Snapchat, this was a concern. So at the end, we didn't really proceed with it for iOS. For Android, it was a different situation. At first, it worked great. It gave us the signals we wanted. We could tell more reliably that the user is using our app or not our app. But then over time, things started to change. The first change was that obviously third-party developers started looking at our network traffic, reversing engineering our communication, and also looking at our Android APKs and seeing what we're doing when we get notification tokens, what should be the behavior. So on the first part, they reverse engineered the flow and they started sending us fake notification tokens. And that was still okay. We had a way, Android provides a way for us to validate that it did indeed come from us. So when we saw fake ones, we could still discard them and proceed with our abuse detection. But later on, it became more interesting because third-party apps were finding ways to generate push notification tokens as though they were our app. And it turned out that basically those developers reverse engineered the way Android obtains these notification tokens and were able to then mint ones for any app that they wanted, including ours. So it stopped becoming a useful defense to us. The one thing also to note is that when you use such an API, you want to keep into account that the API could fail. I mean, those are reliable, but sometimes there are failures on Android or iOS, and notification tokens are not issued or are not issued. So you want to make sure that you don't mistakenly assume that that means the users are all using third-party apps, and just deal with that appropriately. Another approach we thought of, again, server-side, is what if we looked at the way the user interacted with our app, with our APIs, and can we tell if they were coming from our app or someone or another one based on just those interactions with our APIs? And the reason for that is simple. Third-party apps were created usually for single purposes only. And so they wanted really to implement the minimum amount of APIs that they needed in order to achieve the purposes they had. Whereas our app is necessarily more chatty. It wants to use all the APIs that it needs to accomplish tasks, but it also does state synchronization. It could send information for debugging. It could add logging messages. There are many more API calls that it does. So conceptually, you could look at the traffic and be able to tell, is this our app or not? The other thing you could look at is at ordering of APIs and timing of APIs and get a sense of, is that the order that our app uses or not? You can also look at the frequency of login, logout, for instance. You can look at, are the calls coming from unique devices that we know are associated with the user or new devices? We found that these general ideas are actually very, very effective. And they're really very useful signals for us to disambiguate. The only sort of hiccup or a little bit of a problem is that they're much easier to use when we are targeting a specific third-party app, as opposed to sort of a solution that works against any third-party app. And it's a bit of a problem for us because from the beginning, our philosophy was we want to do this in a way that is generic. We don't want to have a bias against specific third-party apps. And so we don't really care about coming up with solutions that are specific to them. So that's the only issue, but otherwise it's very interesting for us. Now, in the case of the user agent example, if you get a user agent that is not ours, we can block the request right away, and there isn't more to it. But in the case of like push notifications or anomaly behavior, you need to look at the requests over time, for instance, within one login session. So at that point, you need to develop a strategy for how do you handle abuse when you see it. You can't just stop a request, one specific request. You need to wait until you have enough signals. And our strategy was to, when we detect abuse, to lock user accounts. And that means basically they can no longer log in, they can no longer send snaps or interact with our systems. But it's a very heavyweight operation, and you can imagine users are extremely upset when we lock their accounts. So we did this progressively. First, we warn them. We tell them, you're using a third-party API. Please change your password and stop doing that, and that's all fine. If they don't follow that recommendation, then we lock their account, but give them a chance to unlock. And if they unlock and still use third-party apps, then we permanently lock their account, and there's no recovery. In order to warn the users, we need to be able to communicate to them. So at first we started sending emails, but for many reasons, sometimes those emails don't arrive. Either they go to spam or the user doesn't monitor their emails. So we came up with additional strategies, namely to send them chat messages from within the app, to give them warnings and then to tell them when their account was locked. The key thing when you're locking an account, which is extremely heavy-handed, users are going to be very upset, and they're going to communicate through tweets or user contacting customer support, and they're going to say, no, we didn't do anything wrong. We're just using the Snapchat app, either because they don't know necessarily the difference between our app and third-party apps, which is an education thing, or because they have very strong reasons to keep their account. So it puts our customer support in a weird situation because now they can't necessarily trust what the user is saying. And in turn, they bring those reports to us and we have to investigate them. The bottom line is that anytime you want to do something so heavy-handed, you have to have very, very strong capabilities to investigate and go beyond and figure out exactly what happened and make very, very sure you don't have false positives. At our scale and our user base, even a 0.01% false positive rate is a lot, and we want to be very mindful of that. Now that we had those frameworks in place for server-side solutions, they're very good, they're effective, but we also know that we have control over our own apps, and we can make them part of that defense mechanism. So we started thinking about early on, we started thinking about how do we augment our mobile apps. And as we were able to deprecate our older APIs, it made more sense to start really leveraging those solutions. The strategies were very different for Android and iOS. So, we'll start with on the Android side. On the Android side, we were at Snapchat anyways thinking of leveraging Google Cloud Endpoint for other needs. And as part of that, we started reading, and we saw that there is this ID token that Android provides. And it can be used for having better confidence that the request that Android is issuing is indeed a request from our own app. So we were very, very interested, and we started looking at that. The way it sort of works is that our mobile app asks Android, give me an ID token. The Android system either has one cached or goes to the Google's auth servers, obtains one, gives it back to the mobile app, and the mobile app sends it to our servers. On the server side, we can check that it's valid, meaning we check that it's issued by Google, signed by their current certificates, that it's current in time so that we sort of prevent replays, and that it's associated with our Android application client ID. This ID token is associated with Google accounts. So if you have multiple Google accounts on your phone, we could come up with a strategy to either use the first one or try all of them, or any strategy to be able to get legitimate ID tokens. In principle, this seemed very interesting because this token tells you whether or not it came from our own app. In practice, it didn't quite work for us. So first problem we hit right away is that you need to have Google Play services installed on that Android device. And there were many Android phones that did not have Google Play. So for instance, Amazon, the Kindle Fire, or some Nokia devices running Android. And we had to make a decision. Do we support those devices, or do we go with this approach? And ultimately, the need for curtailing abuse prevailed, and we stopped accepting Android devices that don't have Google Play. So that part was done. But the part that at the time we didn't know is that the ID token suffered from similar abuse issues than our app does, which is that third parties can reverse engineer the protocol that Android uses to communicate with Google servers, and potentially figure out a way to generate those ID tokens without coming from our own app. They can't do that without knowing the Google account. But it turned out that those third parties started asking their users, give us also Google usernames and passwords. So we ended up with a situation like this. These are 3 separate third-party apps. And they started warning the user, look, we have your Snapchat username and password, but now please give us your Google username and password as well. And really, we thought that this would be, like users would think twice about handing also their Google credentials. That didn't quite happen. So we ended up with a situation where you could have third-party apps on the Apple App Store that pretended to be our Android app and requesting Google credentials as well as the Snapchat credentials. Fortunately for us, at this time that we started struggling with that ID token, Android had come up with a new attestation API. It's called SafetyNet. And that SafetyNet API is designed to better ascertain that the request comes from a legitimate Android device. So there is this compatibility test suite, CTS, that is run on the device, and Android can communicate back whether the device passes those tests or fails them. And the way it interacts, the way our mobile app would use it, is similar to the ID token, with a few two key changes. One of them is that natively this API supports a way to get nonces, so you can really prevent replay. To leverage that, you have to be willing to do an extra round trip to your server to obtain nonces. So your mileage may vary. But also, interestingly, it's not associated with Google accounts. It's associated with devices themselves. Unfortunately, again, for similar reasons that we struggled with, we found that this API had its own forms of abuse. And for a while, it was not really useful to us. More recently, however, we've been very encouraged because in November, the Android security team really, in our view, stepped up their abuse detection and their use, their robustness of the SafetyNet API. And since then, it's become a very valuable defense to us. They have an advantage on us, is that the Google Play is running as root on the device, so can do more checking, and it has a longer history of those devices than we do. So we were very happy that we were able to rely on this API more. A few things to keep in mind if you do use SafetyNet. The API is still evolving. So right now, for instance, rooted devices will show up as devices that are failing compatibility test suite. So you may have to decide yourself whether you want to allow rooted devices or not allow them. But if you do allow them, it's a bit more difficult to disambiguate them from illegitimate devices. And also the error distributions that the API can return, and it returns different errors for different situations, can change over time as their abuse strategy changes as well. So if you rely on those staying constant, you might get a little bit surprised. We expect that over time, this API will give us even more information on what the problem is so that we can factor that in as well in our abuse. So it's more than a sort of a yes-no kind of decision, and that may happen. Also, like other APIs, this one can fail. It's been stable for the most part, but it had like large outages. So you have to make sure, again, you don't lock users when those things happen. For iOS, iOS does not provide similar attestation APIs than what Android provides. So our strategy there was completely different. We thought instead, what if every time the mobile app makes a request to our servers, we sign it? We sign the request, and then server side, we verify that the signature is valid. Now you will say, well, obviously that means the client needs to have a key. So to make that effective, we need to have a way to have keys embedded in the mobile client that are not easy to steal. In fact, they should be very hard to steal. And this is why we worked with a reputed vendor in that space. The vendor provides white box cryptography, which is a set of techniques to embed keys very deeply into code such that it's not easy for you to extract them from that code, and also to mingle them with the cryptographic primitives so that, again, it's not easy to tell the key apart from the algorithm that is being used. They also provide code obfuscation, and the obfuscation is that not only the key shouldn't be able to be lifted, but also any code that is doing the signing should not be able to be extracted from our app and used as a signing oracle. So really the way it works, we bury some keys in our mobile code. They could be using different types of encryption algorithms like public key or symmetric key crypto, or they could be using HMAC or something else. As long as the server can receive the signature and validate that it is correct, then that should be good enough. And because it implicitly assumes that the third parties don't have access to their keys, then they should be able to generate those signatures. And it solves our problem. Now we receive a request from the client. Does it have the right signature? If yes, it's coming from our app. If it doesn't, it's not from our app, and we can reject it right away, which is exactly what we wanted. So really, this solution is great. It lets us, in real time, block third-party apps with the assumption that those apps cannot get our keys. There are some pitfalls to be careful of. Code obfuscation in general is not a joke. There is a lot that goes into it. You have to understand how it works, what it protects, what it doesn't protect. You can't put it for all your code, potentially, because that also increases app startup time. It could be adding a lot more code checking. For Snapchat, for instance, it's yes.
Good question. You mentioned that you're using a vendor to actually, provide the keys, right, and embed that and obfuscate. Can you mention which vendor is it?
No, if I could, I would have. Sorry, just prefer not to. Not because that leads to vulnerabilities, but because I did not communicate with them. I'm sorry, I'm going to reserve the questions to the end, but we're going to leave time for the questions. So there are a lot of things to be wary of when you're signing requests that introduces latency. Even if the code itself is threat safe, it could bring up race conditions and other threat safety concerns in your code, because suddenly there is additional delay that didn't used to exist before the signing. And also because when you're dealing with code obfuscation, it makes development and debugging more difficult in general. So you have to compensate for that and implement processes around it to make sure that developers can still develop on the app. Having said that, sort of the approach on iOS, at least at a very high level, is conceptually straightforward. Embed those keys, implement the right obfuscation, validate the signatures on the server. It still took 3 to 6 months to get an initial well-working solution. So it's not at all technically easy, but conceptually, it's fairly well understood what we needed to do. On Android, the situation was more complicated. Because we didn't want to rely only on attestation APIs, we wanted to implement similar solutions for Android. And there it was more difficult, even at the conceptual level. For one thing, our app is written in Java, and obfuscation in Java land is more complicated, not working as well as native code. Also, because the signing, for those security reasons, we had to port it to native code. We ended up in a situation where we had to create safe bridges between Java and our native code signing. And otherwise, again, you end up in a situation where that code can be trivially lifted and used by other apps to generate those signatures. So we really had to create a way for the native code to trust that the Java code is indeed our Java code and allow those signing requests. Over time, we built this solution for Android, but really the way to get the most value out of it would require that we port all of our app into native code. Without that, it's not as strong and robust as the iOS version. But at that point, we had already implemented it for iOS and Android. We're starting to feel good. Our defenses are robust and solid. And we're starting to get sort of hints from those third-party developers that they're struggling to adapt. And one of them was sending us those messages through HTTP headers in communication. For instance, this is getting messy. So we're feeling better. And let's talk about then where we are right now. So the current challenge. Essentially, we had implemented server-side solutions. On Android, we implemented this white box crypto with code obfuscation, and we also leveraged the Android attestation APIs. For iOS, we implemented white box crypto, but we feel it's pretty robust. And also, we made sure that we use it for all our sensitive APIs, not just, for instance, login. It became really, really hard for third-party apps, standalone applications, to be able to forge those signatures and to pretend to be our app. So the main question for us at this point is, are we done? Is this problem solved? And we realized no. It's still a cat and mouse game. We ended up in a situation where, because those apps can no longer do the signing inside their own apps, they came up with a new twist, which is to leverage remote signing servers. And those signing servers, again, they can't really lift our code, so they actually use our own application. They run a server farm of mobile clients, or we think they do, where they're running our own apps, and they're using them as signing oracles. So the way it works is something like this. On the bottom left, we have our app that is talking with our server. And on the right side, there is a third-party client that wants to talk to Snapchat. And instead of talking directly, it would make a request to a third-party server, say, please sign this request for me. The third-party server would then send it to a signing farm, using our own apps, get the signature, return it back to the third-party app, and then it can pretend to be our own app. This is our current challenge today, where we think we have some good ideas to combat it, but again, it's still a cat and mouse game. And to be able to, for you to know more on where we stand, I think you'll have to wait for our next conference where we have a chance to see how that goes. And just to leave you with a couple of thoughts. So, as Snapchat's product offering grows, we're seeing more and more different types of abuse. Some target new functionality, and we have to think about them fundamentally differently from the initial abuse problems that we were dealing with. Also, as much as we spent on this, we realized there are no perfect solutions. And so the way we're thinking about it now is, let's try to make this abuse more expensive, to get to the point where it's more expensive to circumvent our defenses than it is to get the return on what those apps are trying to do. So sort of make it more expensive than what they would get out of it. And also, we recognize that mobile platforms have a role to play in this. They can work on stronger attestation APIs, and they can also police better their app stores. Now, you will argue, well, there will still be web apps and there would still be command line tools, but really most users interact on the internet these days with mobile phones, so curtailing those forms of abuse would be very effective. And on our side, we know we still have work to do. We have to understand more what users need and we don't provide, and work harder and harder on providing those needs. And this is sort of an intersection of security, privacy, business needs, and user growth. Last point I want to say, we're definitely hiring on all of these fronts: security, spam and abuse, and privacy. So if anyone is interested, please come to our booth or talk to us. Thank you very much. Thank you. Thank you. Sorry, there were some questions. Yes, please.
If your encryption key gets compromised, what are your plans of rotating those and having to deal with the legacy code? And
So fortunately, so far, this hasn't happened. But at the same time, that doesn't mean it can't. And so we certainly have built that in the way we use those keys. We factor that in. We have an ability to recover from those situations.
Yeah, I wanted to follow up on this iOS signature thing.
Yes.
Yeah, we both understand that this is not a perfect solution. I'm just wondering, why didn't you use like a more sound approach, like keychain API available in iOS, or password-based encryption, assuming that like you do have password, you just need to derive the key and do signature. Because all this like obfuscation and embedding, keys, it's just like, deterrent for amateurs. It's not a deterrent for professionals, right?
Okay, so this is a good question. Thank you. Why don't we use keychain and also use password-based encryption? The truth is, this is a situation where our users are willingly giving a third-party app their login, their username and password. You can imagine that anything else we store on the device is potentially also can be given to those third parties. Users may not be using non-jailbroken, like users may be using jailbroken devices, for instance, or rooted phones. So those APIs wouldn't provide the kind of security that we would need.
It's very easy to check if it's jailbroken and say, I'm
Yes.
not going to work with you, right?
Yes,
It's
absolutely.
relatively easy.
It is possible to check if users are jailbroken. Yes. Yes, please go ahead. Oh. Thank you.
Talk about using mobile code obfuscation technology is a really important part of your strategy, right?
Yes.
Yeah, you mentioned that you're using mobile code obfuscation technology as a key part of your practice. My understanding is that to do a security assessment against that technology is not practical because it's very time-consuming to crack it. But to an adversary, it is practical. They will get it eventually, and it's just like encoding. It's not real security. So I just worry, how much do you depend upon that, and are you prepared for it to be broken by a savvy adversary?
No, absolutely. This is a great question. So how much are we relying on mobile code obfuscation, and is that enough against determined adversaries? Certainly, we're not solely relying on that. As we said, our spam and abuse defenses from the beginning are intended to curtail of different forms of abuse, and they've been effective to combat these sorts of problems as well. Also, all our server-side solutions would work regardless of obfuscation. Having said that, thank you. Having said that, this obfuscation, we worked with a very reputed vendor that spent a lot of time thinking about how to make this obfuscation hard. And we ourselves have spent a lot of time auditing to understand, is it really hard or is it not? And we know that it's a very hard problem to solve. So you have to be extremely determined to work on this. It may or may not happen, but certainly this is something we're very keenly aware of, and we're continuously working with the vendor to implement stronger and stronger solutions.
When you do the request signing with that embedded secret key, is that something that you can easily verify with the public key equivalent of that in your system, or do you need a secret key to verify that? And the second question is, when you do have these server farms, signing farms, I would imagine that they have to be hosted somewhere in a cloud provider. Maybe you can just blacklist these type of requests from that kind of IP addresses. So what are the consequences of using that for you?
Yeah, thank you. These are very good questions. So the first one is it really depends what sort of crypto algorithms we use. We have flexibility on that. And yes, pretty much for any that we use, it's very easy to do the corresponding verification on the server. We're not worried about people here for this sort of issue. We're not worried about people compromising our servers and getting access to those keys. If that happens, we have bigger problems. So for us to be able to verify those signatures on the server is not very hard. The second point regarding those signing farms, you're absolutely correct that those are hosted somewhere. However, you have to also see that they're not interacting with Snapchat directly. They're not logging in through those. We don't have an easy way to detect them. They're simply returning content back to the third-party app, and the third-party app on the mobile device is the one that is doing the Snapchat interaction. So there are ways, and surely there are things we can do, and we are doing, to curtail these sort of signing farms, but it's not as simple as it would appear. Thank you.
So,
Okay,
quick
thank you.
question. Oh,
I think okay, one more question.
so, it looks like a lot of people want to get into the Snapchat ecosystem to basically have some interaction and send messages. Was there any discussion, or what's your thought process about having OAuth tokens, or introducing additional partners so users are less incentivized to give their usernames and passwords? Instead, there's OAuth tokens for certain third parties. What's the thought process of Snapchat being closed versus opening it up to other third-party apps?
Sure, this is a very good question. Can we think of an OAuth scheme in order to allow third-party apps to interact with our systems without having usernames and passwords? If it was just a question of OAuth, you could sort of answer it in that perspective. But the truth is, if you do provide any OAuth framework for third-party apps to log into Snapchat without having those credentials, you also want to provide them an API in order to do then the ensuing conversations and being able to achieve certain purposes. In reality, we found that we're still sort of, Snapchat is still growing and still figuring out sort of what the product direction should be. We're still testing a lot of new features. We don't feel we're at the point right now where it's easy to provide a stable API that third-party apps can use and that provides certain functionality. So it's not out of the question for the future. That's part of something we have to be thinking about, and certainly listening to what our users want. But also, it's not a given that at our stage we can provide an API for others and also be very sure that it doesn't alter the experience on Snapchat. Thank you very much.